Hello, everyone, and welcome to another episode of Flawless Execution, a UNICOM Engineering podcast. I'm your host, Daniel Litwin, the voice of B2B. Thanks so much for joining us on this episode of the show. And with this conversation, we were hoping to help communicate the depth of Intel's processors and accelerators, but also try to grasp their transformative role in the sphere of enterprise computing. So with our conversation, we explored why Intel, a globally renowned technological firm, ventured into the market with these specific processors, right? What distinguishes them from the rest of the enterprise computing space? How are they initiating a novel phase in data-centric computing solutions? And we'll also, with this conversation, investigate the business applications of these processors and accelerators to demonstrate how they're redefining various key industries that are going through their own digital transformation in this Industry 4.0 phase, right? So everything from, the domains of artificial intelligence and machine learning to data center efficiency and sophisticated analytics. We'll cover all of that and more, right? So with our conversation, we spoke with Madhu Bramharouthu. He's a technical sales manager for Intel Xeon Scalable Processors at the Intel Corporation. So we hope you enjoyed this conversation with Madhu. We get into the weeds and really break everything down. So get your pen and paper and get ready to learn and then apply some of those grounded use cases to your own adoption of these processors and accelerators. So without further ado, let's kick off our conversation with Madhu Bramharouthu.
What a great introduction, Daniel. Thank you.
Hey, thank you so much. I can always use the validation and a little pat on the back, so I appreciate it. But hey, more importantly is having you on the podcast. Thank you so much for taking some time and for speaking on Intel's behalf here to educate our audience on these scalable processors and accelerators, how they, again, vary from other options in the field and some of their most pressing and useful applications in the field today. Just briefly, so our audience gets a little more context on you, can you give our audience just an elevator pitch on some of your experience and background in the industry?
Thank you, Daniel. So I have been with Intel for about 27 years. All my life at Intel has been with data center. As an engineer, technical marketer, and now I'm in sales and marketing organization. I am the overall Xeon SP technical sales manager.
Well, I didn't realize that we had such breadth of Intel research and engineering knowledge coming to the conversation. So that's exciting, and I appreciate having you here with us again, Madhu. So Madhu, let's go ahead and jump into the conversation today. First, I think our customers want a little more context on Intel's, honestly, their business model approach here, right? Why did Intel embrace the core plus accelerators approach versus solely focusing on their cores, where they already had such a strong market value and presence and brand built around their cores and the use cases for them? Why also break into accelerators?
Great question, Daniel. Let me approach your question in three different ways. First, the marketplace factors are that compute demands have been getting bigger and bigger. Not all workloads created are equal. They require support beyond cores for workloads like compression and cryptography, virtualization, microservices, inferencing, databases, and a lot of other workloads. One need a balance of software and hardware mechanisms. Number two, Intel approach to this complex workload that are out there. Purpose-built acceleration that addresses these critical real-world workloads. Current day workloads do not address these problems, and they do not rely solely on core frequency and or core count scaling. 4th Gen Intel Xeon Scalable Processors offers the most built-in accelerators of any CPU out there in the marketplace today that addresses these workload needs. Cores plus dedicated accelerators drive beyond plateaus for performance and performance per watt created by source-only approach. Finally, you may ask, why should my UNICOM engineering customers care about this? Number one, the 4th-gen Intel Xeon Scalable Processors delivers elevated workload performance, power efficiency plus sustainability gain, total cost of ownership improvements, long-term solution readiness from the 4th-gen Xeon Scalable Processor through the 5th-gen Xeon Scalable Processors and in future.
Well, thanks for breaking that down. I think, getting a closer look at the strategy helps communicate the why, which is really the big picture here, right? If this next generation of scalable processors and accelerators are going to be part of our audience's, the compute ecosystem, it's important to understand why Intel would even get into the space in the first place, right? So now that you've shared that strategy, can you tell me a little bit more about, I guess, the differentiators within the 4th-gen Intel Xeon Scalable Processors and where they really create value, right? What's maybe different from previous generations and also from the rest of the market?
No, excellent question. When you look at Intel journey, we started this journey with the 1st-gen Intel Xeon Scalable Processor about 7 years ago, where we brought not only instruction set-based accelerators, but we also brought IP-based accelerators over the generations. With the 4th-gen Xeon Scalable Processor, you get both IP-based accelerators and instruction set-based accelerators. Talking through these IP-based accelerators, they deliver total cost of ownership against the previous generations of accelerators in 3 key areas, the high level. Number one, that everybody's talking about, ChatGPT, generative AI, and all of that, right? When you put all of that into the AI in a real-time inferencing, the 4th-gen Xeon Scalable Processor delivers up to 55% over previous generation. Databases workloads that deliver up to over 50% compared to previous generations, and HPC workloads that also deliver over 60% over the previous generation. So when you look at the 4th-gen Xeon Scalable processors across wide variety of workloads, they all are trending to be 50% or above of the geo mean over the previous generations.
So then, Madhu, with those, high-level performance benefits, can you tell me a little bit more about the accelerators in the 4th-gen Intel Xeon Scalable Processors? But more specifically, I'm curious what business use cases they solve, right? And so if you could, in your answer, give us some examples of those specific use cases and intersect them with the technology foundations of the accelerators, I think that'd be really useful for our audience.
Absolutely right. That's exactly what we are here for, is what's in it for me. It's great for Intel to talk about performance, but at the end, it has to solve an end customer problem. How is 4th-gen Xeon Scalable Processor with these included IP-based accelerators delivering the value to UNICOM Engineering customers? So let's peel the onion across these 4 different accelerators that I'm going to walk you through today. First, let's look at the Intel Quick Assist technology. In short, people call Intel QAT. What is Intel QAT? Intel QAT delivers accelerated cryptography and data decompression. That's the simplest form to say what is QAT. What is the business value of Intel QAT? You can look at it in 2 different ways. One, it accelerates compression and decompression by offloading that leads to greater CPU efficiency. 2, more encrypted connections and web secure connections between devices with less overhead. And the use cases that includes to support this Intel QAT across distributed storage systems, file systems, RocksDB, data lakes, Apache Spark, Hadoop, and Nginx. Because the QAT has been in existence for over 2-3 decades now, there is a very large software ecosystem behind it because people have been using the discrete card until now. Now that we pull the QAT, the software hasn't changed. The software will continue to be that. And Intel is working with the software vendors to optimize and make it seamless to our customers. Because of that in software readiness, now let's look at the performance of that, right? Because software enabled, let's look at the performance. Looking through the lens of network secure gateway applications. Intel QAT delivers up to 84%, really up to 84% fewer cores to achieve the same connections on Nginx with built-in QAT versus out-of-box software. I want to repeat that. Up to 84% fewer cores to do the same amount of work with QAT built into the CPU versus the software. For enterprise storage and data analytics, Intel QAT delivers up to 2x higher level 1 compression throughput, leveraging the integrated QAT versus the previous generation. So it's amazing performance with built-in QAT. Second, Intel Data Streaming Accelerator. In short, you can call that Intel DSA. Intel DSA, in simple terms, to say it optimizes streaming the data that's coming into the server system. The business value of Intel DSA is to accelerate data protection for NVMe, TCP/IP, improving efficiency for data storage applications via offloading the CPUs. The use case for this includes virtualization, fast replication across non-transparent grids, ERP solutions, in-memory databases. Software ecosystem is building. This is the first instance of the accelerator that we have added into the 4th-gen Xeon Scalable Processor. Ecosystem will continue to expand on this. Intel has the biggest software ecosystem partnership. But to talk about the performance, with DSA, we deliver great throughput performance and at the same time reducing the latency. So when I talk about throughput, Intel DSA delivers up to 70% higher IHOPS for SPDK and NVMe with built-in DSA versus the software, the ISA software. At the same time, we are reducing the latency by 37% for large packet sequential reads with built-in DSA versus the previous generation. So no matter what you look at, the existing software under the previous generation, 4th-gen Xeon Scalable Processor with Intel DSA not only delivers great performance, but also reduces the latency. Number 3, the Intel Dynamic Load Balancer, short form Intel DLB. The Intel DLB does dynamic redistribution of data load across these up to 60 cores we support in the 4th-gen Xeon Scalable Processor when the static NIC distribution causes a load imbalance. So by having the Intel DLB, the system improves performance related to handling all of this network data that's coming into this multi-core Intel Xeon Scalable processors. It also improves performance for distributed processing, dynamic load balancing, and dynamic network processing reordering. Use cases include IPsec security gateway, the VPP router, vSwitch, streaming data processing, and elephant flow handling. Again, like DSA, the software ecosystem is building with the DLB. We continue to work with the software ecosystem partners, improving the software readiness. All of these details are available through the UNICOM Engineering. Please contact your representative at UNICOM to find out the application readiness with respect to DLB and DSA. Intel DSA delivers up to 70% higher IOPS for SPDK NVMe with the built-in DSA accelerator in the 4th-gen Xeon Scalable Processor. And the fourth one, which is the last of the IP accelerators that I wanted to talk to you today, is the Intel In-Memory Advanced Analytics Accelerator. It's a mouthful. In short form, Intel IAA. Isn't that easy to say, Daniel?
Definitely much easier than the alternative.
Exactly, I agree. And that's why each of the accelerator we said, hey, you can just call Intel IAA or Intel AMX, Intel DSA, just to make it easy so it's easy to roll through your tongue.
Sure.
So like the three accelerators that I have talked to so far, Intel IAA is also an integrated IP accelerator that accelerates analytics primitive, CRC calculations, compression and decompression. With Intel IAA, the query throughput for in-memory databases increases and for also analytic workloads. At the same time, decreases memory band. See, this is what I was saying. It's rolling the tongue, right? Not only you're decreasing the memory and bandwidth footprint for analytic workloads, but you're freeing up the space on the CPU by offloading the work onto the Intel IAA accelerator. It has a wide variety of use cases that includes commercial in-memory databases, open source in-memory databases like RocksDB, Redis, Cassandra, MySQL, and MongoDB, to name a few, and also columnar formats for big data analytics. The in-memory software like the Intel DSA, Intel DLB software ecosystem continue to expand, including all the applications that I mentioned that are ready to go today. With respect to the performance, the Intel IAA delivers up to 3x, not 30%, 3x higher RocksDB performance, but at the same time, lowering the latency by 66% over previous generation. I want to note here, previous generation did not have these IP-based accelerators. So because of 4th gen having these IP-based accelerators, you're getting 50%, 100%, 200, in some cases going up to 10x performance improvement. So a lot of performance improvements because of the accelerations that we put into the 4th gen Xeon Scalable Processor. And lastly, about the IP-based instructions. So far, I talked about 4 accelerators that are specifically having an IP block on the CPU. Now let's talk about the instruction set-based acceleration. Intel, do you know, by the way, Daniel, Intel was the first one to bring inferencing into the data center CPU.
Intel has a lot of firsts. That's another one to put in its cap.
There you go. So we continue to be on this journey of making or adding more value into the Xeon. So when an end customer of UNICOM takes this, it solves their problems better compared to the previous generation at a lower cost. So what do you mean by that? Let me just walk you through of this IP-based instruction set today. Intel Advanced Matrix Extension. Short form, another short form to make it easy for you, Daniel, and for the UNICOM Engineering customers, Intel AMX. It provides extensive hardware and software optimizations to enhance AI acceleration. Intel AI software suite enables out-of-the-box performance and end-to-end productivity. extensive partnership like the ones we have with UNICOM Engineering and your customers. This is what we need for us to accelerate end customer time to market. It's about the partnership. It's not just about bringing a technology. It's not about bringing a technology with all the software system. It's the entire ecosystem, including the partnership with UNICOM Engineering. And that's how we deliver significant performance improvements or increases for AI and deep learning inferencing and training workloads, delivering common applications faster throughput through this hardware acceleration. There are a lot of use cases with the AI. I mean, we have been talking this for generations already across image recognition, image classification, recommendation systems, machine language translation, natural language processing, media processing, and delivery, to name a few. People always ask, hey, it's awesome to bring this acceleration in the CPU, but I use the frameworks that are out there in the open source. So we have optimized and ready to deploy these market relevant frameworks and toolkits, libraries that includes popular ones like PyTorch, TensorFlow. As always, Intel One API, the deep neural network library, is ready to go. So software ecosystem has been in existence for multiple generations. We continue to optimize on the software side while we bring new instruction set and accelerations within the CPU. Going a little deeper into the performance, Daniel, with the Intel AMX, we deliver up to, so far I've been talking 50%, 100%, 200%, but AI, which I said the first data center CPU to have inferencing in the processor, delivers in the 4th gen 8.6x higher speech recognition inferencing because of the new acceleration and the software optimization that we have done in the 4th gen Xeon Scalable Processor. PyTorch training and inferencing delivers not 8x, 10x higher for both real-time inferencing and training performance because of the built-in AI acceleration engine in the 4th gen Xeon Scalable Processor. But it's not about just comparing to the previous gen, Daniel. So let me just give one final tidbit about how it compares to a GPU. I know we are not in the space of comparing a CPU versus GPU, but I thought I'll just drop a statement there. GPU has its own place. We get that. When you want this deep learning, deep training model that you need to do, absolutely. But Xeon runs hundreds and thousands of workloads. In addition to that, when you compare inferencing, because Xeon inferencing is done mostly on Xeon, not on the GPU. So when you look at inferencing, can you guess if Xeon under-delivers or over-delivers with respect to NVIDIA GPU? Can you guess?
I mean, I would have to assume the answer is pretty straightforward, which is it overperforms.
Oh, you are so good, Daniel.
Look at me, I'm so smart.
So we deliver up to 1.8x higher average the inferencing performance with respect to NVIDIA A10 GPU. But it's not just inferencing. Also, on the training side, mainly fine-tuning. Like when you look at the training models, most of the models are pre-built. So you take the pre-built model, you fine-tune those training models. So when you are talking about this fine-tuning of these pre-built, pre-trained training models, Intel Xeon's 4th gen Xeon Scalable Processor actually delivers almost the same performance as of an NVIDIA GPU, a 100 card. So not only you get all the things that hundreds and thousands of workloads that you're running, including inferencing and training, it's there. So Xeon, when Xeon does everything for you, why would you even consider an add in GPU card? I get that. When you need it, absolutely you need it. But for inferencing and most of the pre-trained training models, you can use the Xeon.
All right, Madhu, I feel like we got the most in-depth analysis there possible. We went over Intel QAT, Intel DSA, DLB, IAA, AMX, their various use cases. That might have been a lot for the audience to walk away with. So if they need a quick refresher on that, where should we point them online so they can peruse some of this for themselves and get a sense of Intel's fourth gen Xeon Scalable Processors suite?
So I always recommend to go to UNICOM Engineering website to go find additional information, but you can always go to intel.com, look for the fourth gen Intel Xeon Scalable Processor to find additional information.
Perfect. And just to kind of, take all of that breakdown and some of those higher level use cases and get more strategic, where should the UNICOM Engineering audience here, where should they, first try to deploy some of these fourth gen Xeon SPs for their most pressing business use cases and needs, right? Do you have any sort of strategic advice on how to maneuver this suite and how to put them to best use immediately for some of the, the workloads that are shaping next generation compute?
So Intel Xeon, like I said, runs hundreds and thousands of workloads.
Right.
That's the baseline, the foundational, right, for all the workloads. In addition to that, because of these accelerators that we put in, today I walk you through of AI inferencing and training when you have those requirements, mainly trying to do analytics kind of a workload for in-memory databases or workloads like that. Absolutely, we recommend AMX. This is not the first generation. It's an evolution of inferencing that we brought with the previous generation. That's number one. Number two, we have a lot of workload optimized SKU offering. Like if I may take an example of a car, you take a BMW as an example. You have a basic car, you have an optimized car, like a sports car or a racing car or a SUV for that matter. Similarly, on the Intel 4th Gen Xeon Scalable Processor, we have workload optimized SKUs. You look at the in-memory databases, you look at the network, you look at the high-performance computing, we have optimized those applications and workloads already for you. When in doubt, exactly to find out which SKU for what workload, please talk to your representative at UNICOM Engineering. They can guide you through finding the right SKU for that right workload. With Intel 4th Gen Xeon Scalable Processor, we have built a product that is workload first approach to innovation, design, and delivery of these workloads. We have the most built-in accelerators ever in a data center processor and delivering great performance and efficiency to our partners like UNICOM Engineering and to UNICOM Engineering customers.
And yeah, I think you hit the nail on the head there, Madhu. While Intel's fourth generation Xeon Scalable processors might have some fields where they're seeing some of the most cutting edge and innovative use cases, the whole point is that these scalable processors are workload agnostic, handling thousands and thousands of different types of workloads. And that's, I think, why they're proving to be so valuable and exactly why our audience should dig in for themselves, look at the suite, and get a sense for how these scalable processors and accelerators can start to be put to use for your business needs and your use cases. So I think with that, we'll go ahead and wrap up the conversation. Madhu Bramharouthu, Technical Sales Manager for Intel Xeon Scalable Processors at the Intel Corporation. Madhu, thank you again for your time today. It's really been such a pleasure. If folks want to get in touch with you, maybe pick your brain a little bit on some of the more specifics of the various processors and accelerators we broke down today, where can we point them?
So as always, we recommend the customers reach out to the UNICOM Engineering representative.
Sure.
And Intel is a very large company. I am one of the many people, and I'm always accessible to UNICOM Engineering. We have our own account team that supports UNICOM Engineering, and they know who to contact for specific questions.
Love it. Well, you heard it there, folks. Make sure that you are heading to our website, unicomengineering.com, to not only maybe get in touch with the Intel team, but also just to learn more about Intel's 4th Gen Xeon SPs and accelerators to get a sense for where they can apply for your workloads and business needs. So Madhu Bramharouthu, thank you again for your time. It's really been such a pleasure, and I'm looking forward to learning more from you next time. Hopefully our audience here got some imaginative ideas flowing for how to put these SPs to work. So thanks again for your time.
Awesome. Thank you, Daniel.
And thank you, everyone, for tuning into this episode of Flawless Execution, a UNICOM Engineering podcast. Head to our website and make sure that you're subscribing to Flawless Execution for more thought leadership and to catch up on previous episodes on both Apple Podcasts and Spotify. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of Flawless Execution.